For an additional example with linear programming, let's try the following problem. You need to buy some filing cabinets. You know that cabinet X costs $10 per unit. It requires 6 square feet of floor space and holds 8 cubic feet of files. Cabinet Y costs $20 per unit, requires 8 square feet of floor space, and holds 12 cubic feet of files. So square feet is talking area, cubic is talking volume. You have been given $140 for this purchase, though you don't have to spend that much. The office has room for no more than 72 square feet of cabinets. How many of which model should you buy in order to maximize storage volume? Try to set up the beginning equation, so pause the video for a minute, set up your variables, try to write your inequalities, and then hit play to get your answers. Make sure you get an understanding of what you're doing. So now setting up this problem, you can see that I color-coded and underlined the important information here. We have cabinet X and cabinet Y, so we're going to let X represent the number of model X cabinets purchased and let Y represent the number of model Y cabinets purchased. We have two situations that we're setting up, cost and space. Now it should be noted that obviously the number of X filing cabinets has to be greater than or equal to 0, and the number of Y filing cabinets has to be greater than or equal to 0, because otherwise it wouldn't make sense. It's a real-world situation. I can't buy negative cabinets. Now for our cost inequality, cabinet X is $10 per unit, so 10X. Cabinet Y is $20 per unit, so 20Y. And we can spend only up to $140, so less than or equal to $140. And then you can see here that I got it into standard form, so in the form of a linear equation, which is going to be our boundary line, y equals mx plus b. Now for the space that it's going to take up, the space that we're talking about is the floor space, so the area, not the volume yet. We want to maximize the volume, so that's going to give us our equation in a minute. So we have 8 square feet of space for cabinet Y, so that's our 8Y, and 6 square feet of space for cabinet X, so that's our 6X. We only have 72 square feet of space for cabinets, so no more than means less than or equal to 72. And that again gives us, when we get it into how our equation for our boundary line is going to look, y equals mx plus b, so we get y by itself. Now, we want to maximize storage, so we need to create a function or an equation to maximize the volume. Well, for the volume, we know that cabinet X holds 8 cubic feet, so 8X, and cabinet Y has a volume, holds 12 cubic feet, so 12Y. So the volume is going to equal 8X plus 12Y. We need to graph our system of inequalities, so these 4 inequalities. And then from that, we're going to get a shaded region. That shaded region is going to have vertices. We'll find those vertices and plug them in. To maximize, we're going to pick the biggest number. If we were minimizing, we would pick the smallest number after plugging in the coordinates for X and Y. Now again, take a moment, create your graph, and graph the following inequalities on your coordinate plane, shading where you're supposed to be shading. If you'd like, you can just shade the region in which they overlap, but make sure you're sure as to what that region is. Otherwise, shade all 4 proper regions and then put a giant S in the area where they all overlap. Make sure you have a table for each, and you've written just as I have whether the boundary line is solid or dashed and whether you're shading above or below. Take a minute and pause the video and then press play when you want to check your answer. We'll go over how to maximize the function together, but graph it on your own. We have our inequalities graphed on the number line, and they're labeled with the inequality symbols. Our overlapping region is shaded, and again, if you shaded everything, make sure you put a giant S in this solution region. But in order to maximize our original function, we need to look at the vertices of that shaded region, and there's always going to be vertices here. Well, it's obvious that at the origin we have 0, 0. Here, we have actually on my table over here at 0, 7. Over here, again, we have on my table for our red inequality is 12, 0. It's here that we're going to have to find the solutions. So if you type into your calculator these two equations for the boundary lines and you solve them for where they're intersecting, so you graph them and then you press second calc intersect, you'll get the coordinates for this vertex, and then we'll be able to plug them into our function to maximize. You'll see that they're intersecting at the point 8, 3. So we have our 4 vertices for our shape. We're going to plug them into our function to maximize. So 0, 0 is going to give me 8 times 0, which is 0, plus 12 times 0, which is 0. So the volume would be 0. 0, 7 is going to give me 8 times 0, which is 0, plus 12 times 7, which is 84. And we're talking here in cubic feet. 12, 0 is going to be 12 times 8 plus 12 times 0, which is going to give me 96 cubic feet. And then our final point, 8 times 8, which is 64, plus 12 times 3, which is 36, is going to give us a total of 100 cubic feet. So you can see that the point 83 maximizes our function, so that would be the solution. You would need to state your final answer must be in sentence form. To obtain a maximal volume of 100 cubic feet, you must buy 8 of model X and 3 of model Y. It's a big, lengthy question, but it would probably be like a part 4 Regents question, which is why it's so important. On a test, this is like a 6-point question, and you need to include every single part.